Good morning from Ellensburg, Washington, USA. Happy New Year. The local time is 8:54 a.m. and today's date is the last day of 2023. It's December 31st. Thank you for tuning in to this episode. I'm talking to you replay viewers. Thank you for finding this, and I hope that you enjoy this episode. Episode L, called Satsop Gravels. Now that I've said that, my blood pressure is up because the whole system crashed just a couple minutes ago. So I've got to find the live stream, see if we're functional, see if we can get our live viewers back. They were all waiting. We had more than 200 waiting at the other stream. So give me just a second here. And if you are watching in replay, it's going to be at least 6 or 7 minutes before we get started with the program. I can't promise the top of the hour because it's going to be a few minutes, but I'll put a chapter title in after the fact. I'll put a chapter title so you can skip ahead to the beginning of today's program. Thank you. Woo boy. Okay, so let's find this program and see if we're 5x5. Good God. Okay. Hi, everybody. Hi, live viewers. We have 200 already. So you found this new stream and we're 5x5. Okay. Wow. Give me another second. Calm down, boy. Calm down. Calm down. I say it's not going to be at nickzentner.com. It's going to be here. Got it. Oh, okay. Let's say hi to just a couple of you. Make sure that we are functional, and then I will email our guest, Kelsay Stanton, over in Spokane. So deep breath, yes, thank you. That was weird. I agree. There's always new things, always surprises. Happy New Year to everybody. It's December 31st. Warren, Maine, and Lake Ozark, Missouri, and Dayton, Ohio, and everybody's saying 5x5, which means loud and clear. Okay, well, great. So we have 235 and more trickling in. Let me pause and see if I can email properly. I really don't know what happened there, but don't think about it. Add the guest, talking to myself. Email Kelsay Stanton. My goodness. There that goes. Check my pulse. Did I even do this yet? I don't know. The local time is 8:57 a.m. and today's date is December 31st. I think I did do this. Okay. An abbreviated session of saying hello to people. Where are you viewing from? And are you if you're in Europe or other places in the world, are you already at a New Year's Eve party and you're hiding in some broom closet to watch this thing? Rainy San Diego, Wenatchee, hello, Jason, Moto JW, Helena, I almost said Helena, Montana. I'm a little scrambled. I'll get myself calmed down. Don, you're from Elma. We're talking about your turf today. Costa Mesa, West Tennessee, Houston, Texas. That's John. Penticton, British Columbia. That's Janet. Hello from sunny Kirkland, Carlisle, Pennsylvania, Carlton, Oregon, Brussels, Belgium, Fairbanks, Alaska, where it's minus 15 degrees Fahrenheit. Thank you, Don. Your weather report always prompts me to show everybody what's going on. So yeah, still no snow here, much in the Pacific Northwest. We're just waiting for some kind of snow. And looks like the cameras are working properly. And we are on our schedule. And here we are on December 31st, and we will get to the next episode after the new year. Okay, Kelsay, can you hear me, Kelsay? Oh, wonderful, 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 wonderful. Thank you, Kelsay. That makes me happy. So Kelsay's in the green room, and she will be muted and silent, watching in the green room for the next 20, 25 minutes, something like that, and then we will bring her in. And Kelsay, if you wanted to share your screen, that would be a separate thing. We can do that. I do want to make a couple quick announcements. So we're not going to quite make it to the top of the hour for those that are watching live, but yeah. Thank you for joining us. Smile, fake smile. It'll be genuine in a few minutes. I hate that when there's this unexpected stuff. So I just have to share this to get it off my chest. I get in here an hour early. I have everything plugged in. I reboot the computers. I have everything just right. And then for the first time ever, I think, all I did was hit live with the scheduled live stream, and the whole thing just quit. And the live chat went away, and there was no way to communicate with you. Never had that happen. So rebooted the computer, did everything. This is not the scheduled live stream, but it looks like we have more than 450 finding us. So if you're watching this in replay, you're like, big deal, start the program. I get it. But, we got a bunch of live viewers, and they're part. You live viewers are part of this, a big part of this. And I just need to calm myself down. Okay, let me close email because we have Kelsay. Get rid of that. I wanted to make one announcement. No, I want to make two announcements. I want to remind you, first of all, desktop. Thank you. You remember this guy, old David McWalter. This is still the plan. I think the fog's supposed to lift by noon, and it's supposed to be sunny and in the 40s. And so as soon as I'm done here, I'm going to drive up to Dry Falls and at the visitor center. So if you were planning on doing that or forgot about it and you live within a couple-hour drive of Dry Falls, if you want to visit, a bunch of us are going to be there, it sounds like. So David is ready for everybody. David McWalter, the park ranger at Dry Falls State Park. And winter conditions, but all that means is temperatures. It's really spring conditions. There's no snow on the ground, essentially, and it'll be in the 40s, I think. So let's go up and get rid of this cabin fever that some of us are experiencing, and we can do that. So I'll see some of you in just a few hours. What's the other announcement? The other announcement is school is about to start here. The students will be back starting on Wednesday. And so we are resuming our Fridays at noon live stream lecture series. And you are, of course, are welcome to tune in live to these, or even if you want to come in person, you're welcome to come in person. So this is in Discovery Hall here, but I'll be live streaming, hopefully, each of these. Logan Weatherall, who works here, will be giving a talk on landslides in the Northwest. That's this coming Friday. I need to take some of these cameras and walk them down to the auditorium. Kelly Wall, USGS. I think she's talking about the Goat Rocks, but maybe not. Susan Kaspari, who teaches here, just got back from a Fulbright in Norway, so she'll talk about her experience in Norway as a Fulbright scholar. Marie Takach is an instrument tech person here in the department. So, in winter, it's tough to travel normally, and so we schedule people in the building, basically. And then there's a new geothermal energy project here on campus, and Anthony is from Spokane. He'll be driving over on March 1st. So I'll remind, I guess, on Thursday's show, this coming Thursday's show, I'll remind you of that again. But there'll be some extra live streams coming your way if you are interested. Okay, we got 600 here, and all the stations appear to be working. Kelsay's in the green room. It's 9:02, but you're going to have to give me 3 minutes. I got to go get my head right. I got to calm down, okay? So we will begin the program in 3 minutes at 9:05, and I'll give you a glorious shot of essentially nothing outside. Thanks for joining us, everybody. Thanks for joining us, everybody. See you in 3 minutes. Hot mic. Good God Almighty. I'm late. Good morning, everybody, and welcome to Central Washington University, Ellensburg, Washington, USA. I'm your host, Ned Zentner. And today, on the last day of 2023, we're devoting an episode to something called the Satsop Gravels. Kind of a strange topic. It's in Western Washington. And we have a guest, Kelsay Stanton from the Washington Geological Survey, and we'll bring Kelsay in about 25 minutes. But my job here is to set the context for that conversation. And most of what we will do with Kelsay is off the cuff. I tested the audio visual stuff with her yesterday, but as usual, we didn't hash things out. So it'll be a spontaneous conversation. And so part of what I'm doing in this first 20 minutes is to give something for Kelsay to play off of. And it's also to set the tone for what we want to do here today, because what have we been doing? Ice Age floods, but you're like, not really. You haven't been to Eastern Washington yet. I don't know why you're screwing around with all these other topics. Get to Eastern Washington. That's you talking. Well, we'll get to Eastern Washington on January 11th. A week from this Thursday, we'll be in Spokane, not physically, but the series will finally arrive in Eastern Washington. But I think we need 3 more episodes, including today, to get us to Eastern Washington and to continue to follow the timeline of our boy, Harley Bretz. So let's start with a quick little analogy, or at least a phrase or a saying that I think will tease not only today, late today, but into the next couple of shows. Following the breadcrumbs. You know that phrase? Following the breadcrumbs? I don't really know the origin of the phrase, but I imagine it's something like back in the olden days, somebody's like, well, I'm going to go take a walk. I'm going to go take a hike through this thick forest, but I'm not sure I can get home. And I don't have an iPhone, and I don't have anything. So I'm going to be smart about this. I'm going to just grab a loaf of bread from the house. Maybe it's a French baguette from Vindman's Bakery. You've got to love it. I'm going to be smart about this. I'm going to take this bread, this baguette, and every 17 paces, I'm going to take off a little piece of this baguette and drop it. I'm going to make a breadcrumb. I'm going to walk another 25 paces, another breadcrumb, so that when I finally turn around, I'm thoroughly lost, but I'll just follow these breadcrumbs and get myself back home. That's my version of what that phrase means. Well, today, with the Satsop Gravels, especially late in our conversation with Kelsay, we're going to stumble into some breadcrumbs that Bretz was finding in the Satsop red gravels. And they're gravels. They are stones. They are like river rocks. Out here in the West, we have rivers that run clear, and you can just go right into the bottom of that river channel, and you can pull out these beautiful spuds, these beautiful potatoes. They're rounded and polished. They're made out of rock, but they're gorgeous. And of course, a river channel has many different kinds of stones in there that all the tributaries have brought those spuds, those river rocks to that particular channel. Well, the spuds today are rusty and they're rotten and they have antiquity. And they're stained to the point where Bretz says, let me show you. Bretz says, yeah, you look at these rocks, and in some cases you can hit them with the hammer and they just crumble, they just shatter. And some of them are decomposed enough that you can take a knife and just cut right through them. And yeah, there's some granites in there, but there's also some volcanics and everything else. Bretz apparently was obsessed with these Satsop Gravels for a number of years, back in the teens. We're between 1910 and 1917 today. And in that pile of rotten red gravels of antiquity, there's some stones that don't belong. They're exotic. And so he starts following these exotic stones. And he starts following them up the Columbia River. He suddenly is out of Western Washington and Western Oregon. He's in the Columbia River Gorge. He keeps following these exotic river stones, these spuds that don't belong. And before he knows it, he looks up, he's in Eastern Washington. He's home. And so in the next 3 episodes, we're going to follow Harley as he follows the breadcrumbs. And it's more than just river stones that are going to be the breadcrumbs. But for today's episode, that's the case. Okay. Off to a good start, I think. Now, can I keep the momentum going? Can I even pick up the pace? That's the question. I'm going to give old Docky, the document camera, a workout. I've got hardly any slides today, but I've got a bunch of notes and Sharpie cartoons that I hope that I can then set up our conversation with Kelsay. Are we doing okay before I do this? We're still fine. Yuki, thank you. It's 5x5. Good. So let's give Docky a workout. So previously on St. Elsewhere, we had multiple ice advances with the coloring scheme back in the Midwest with T.C. Chamberlain and Rollin Salisbury. And we focused on the fact that, at least in the olden times, there were multiple ice advances that were mapped. We zoom in on Washington, Eastern Washington and Western Washington. By the way, I found this recently, and one of you viewers, I hope you're still with us. This is back in the pandemic, and if I start telling the total story, I'm going to start crying, so I don't want to do that. But this was an important pointer for somebody's dad or professor that was influential, and they gave it to me. So I'm going to use this thing. Thank you. All right, keep it together, boy. So Western Washington, Eastern Washington, Vashon ice over Seattle. And this is from the last show. I'm trying to go fast. Stage 2, stage 4, stage 6, the double bluff as it's known today. And I was wondering, I had my scissors out, remember, I was like, what happened to the Spokane ice sheet and the Cheney ice sheet? Why are we just talking about the Okanagan? Okay, keep it going. Also from the last episode, I was then wondering about if we restore the Spokane ice sheet in Eastern Washington, as Bretz was doing in the 1920s, therefore he had a mega glaciation and a mega flood, the Spokane flood, that eventually is coming down the Columbia River Gorge. And Bretz was not talking about an outburst flood coming down the Chehalis River to Aberdeen, but there's a nice symmetry here. And Bretz was talking about at least two different ice advances, the Vashon and the Admiralty. And today, our red gravels of the Satsop are here between the southern margin of the ice sheet south of Olympia and Aberdeen and Grays Harbor. And our guest Kelsay has done detailed mapping recently, Grays Harbor and Willapa Bay, among other places. Keep it going. We're going to take a break from the detailed old guy chronology business and the biography stuff, but you remember we were talking about Chamberlain and Salisbury and Bretz and the beginning of the University of Chicago's geology department, and Bretz is coming in here. I only show you this because we're in this portion of the timeline as Bretz is transitioning from Seattle to Chicago. I have a new way to show that. And that involves the papers that wait for you at nickzentner.com today. So here we are talking about Harley Bretz. And these are the dates. He's teaching Seattle High School for 4 years. He then goes and gets a PhD with Chamberlain and Salisbury for 2 years. He comes back to the University of Washington for 1 year. And then he starts his full career as a professor at the University of Chicago. We drill down to these papers for today. And there's a little tease for the next couple of shows. Margaret in Spokane and Jeff in Portland managed to tip us off about some Bretz field notes that nobody knew about in downtown Portland. And that will be featured in the next couple of episodes, thanks to Margaret and Jeff. But a 1910 paper, a 1911 paper, a 1913 paper, a 1915 abstract, a 1916 draft that was in with the notes that Margaret and Jeff discovered. And then finally, a formal paper on the Satsop Gravels in 1917. All of these are being featured today. And so I want to go through my notes quickly from each of those papers, and then we'll play off of things with Kelsay. Okay. So I was struggling with geography. I don't live in Western Washington. I knew roughly where the Chehalis River was, but I couldn't picture where the Cowlitz River was flowing and everything else. So I made a map for myself. And maybe this will be helpful, especially when we visit with Kelsay. But I think she's going to get us on Google Earth or Google Maps and fly around as well. So the idea is Mount Rainier Volcano, Mount St. Helens, Mount Adams. Here's Portland, Oregon. Here's Longview, Washington. Here's Astoria, Oregon. So this is the Columbia River, the main river. And Bretz is eventually going to work his way east and walk his way with his University of Chicago students. He's going to work his way up the Columbia River to Eastern Washington, AKA the Promised Land. But today, we are south of Tacoma. We are south of Olympia. We know the ice sheet was on top of those two cities more than once. But it's the Chehalis River flowing to the Aberdeen area and Grays Harbor. It's the Cowlitz River coming from Rainier, going down Packwood, US 12, Morton's in here, Mossy Rock, and then getting to Longview. So I-5 is right through here. And these green lines are divides. And you remember the concept of divides. a number of letters ago when we were talking about a divide, and then we have dendritic drainages on both sides of the divide. Well, we're back to those concepts today. I'm not showing the dendritic tributaries going into these two rivers, but the point is you can go from PL to Chehalis to the little village of Satsop, where the Satsop Creek is coming in, and that's the Chehalis story. The Cowlitz River is coming from a completely different area, sourced with different kinds of rocks. So the bedrock here is different than the bedrock in these rock hills in southwestern Washington. But the point is we have leakage. We have the ice sheet multiple times coming down over Puget Sound, and we have water spilling over this divide. Red for Vashon, blue for Admiralty. Stage 2, stage 6. And how much of this Satsop Gravels story is tied to this spillage of the ice sheet? That's what Brett's is wondering initially, but then as he works his way south through these red gravels, he starts finding surprising things within the red spuds. Still trying to get things going. This is from the last show using Joel Gombiner's numbers, Joel the Wonder Boy. So stage 2, stage 6, stage 12, stage 16, those are our working stages for major ice advances worldwide, but including Western Washington. So we're going to use these numbers again today. Kelsay might not like it, but we're just going to use nice round numbers based on the marine isotope stage record that we have. 20,000, 150, 450. I don't think we're going to go any older than that today. But I haven't pointed it out before, but I think it's going to come up with Kelsay. There are odd-numbered marine isotope stages as well, and those are interglacials. Those are warm times. So we might be talking a little bit about stage 3 or stage 5 or stage 7. And if you're confused, the odd numbers are warm times. The even numbers are cold times when we have glacial advances, some more major than others. How are we doing so far? Doing all right? I'm going to keep it going fast. I promise I'm not going to waste Kelsay's time a whole lot more, but I feel like this is needed. And I know roughly where we're going with Kelsay, but there's going to be some surprises as well, I'm sure. Keep it going. So I'm not even going to bother going to the website. Instead, I'll just show you the papers. So I just had a good time with Brett still as a high school teacher in 1910. And this is his first published paper with those rivers south of Olympia. And 1911, he's wrapping up his high school teaching career in Seattle. And I colored red for Vashon. Here's the big divide. Here's the Chehalis River heading to Aberdeen. I needed to do this mainly for myself because I just couldn't quite picture it when I was reading the words. Okay? Quick notes from those first two papers. He's mostly red in the first paper. He's mostly stage 2, Vashon, and he's working out relationships between glacial lakes and spillways. And this is Lake Sammamish, this is over by Preston, this is all sorts of things. But there's a low gravel plain in the Chehalis River that he points out. I'm fumbling here because I'm looking for, okay. And it's in this first paper. It's in this first paper, 1910, that Bretz writes, it seems fitting that to this lake of Puget Sound during Vashon time, with outlets southward through Black Lake Channel and with levels controlled by that channel, a name should be given in tribute to the work of a geologist to whom our knowledge of the physiography of Western North America must always be deeply indebted. In memory of Israel Cook Russell, may this water body be known as Lake Russell. We know a lot about stage 2 glaciation in Puget Sound, including Lake Russell. And there's even something called Lake Bretz. I don't know if you've figured it out by now, but I'm just not that interested in stage 2. I'm getting a lot of emails, and I appreciate all the emails. A lot of them are like, hey, check out this, check out this, check out this. And it's all 20,000-year-old stories. I'm interested in the older stories. I feel like that's the story, that's the part of this that is undeveloped or poorly understood or whatever. So, yeah, We're not talking about Glacial Lake Russell because it's a Vashon age story and very cool stuff, but not the focus of what we're doing here. Yeah, Bretz was doing a bunch of stage 2 stuff. He didn't know it at the time, but he was. That's not what we're doing in this series. Okay. Water escape into the Chehalis. Very good. Now, 1911, he's looking at the moraine and he's calling something extra morainic outwash. Willis and Russell before Bretz, 2 glacial advances, the Admiralty and the Vashon. You remember that. So this is a little bit more rough looking, but we've got our stage 2 and our stage 6. Suddenly Bretz is talking about something called the Dewato till, which I've never heard of. Stage 12, nobody uses that term anymore. Is that the Defiance? Is that something else? Okay, you kind of know where we are, and we're teasing out these different ages. Good. He's mentioning, not by name, but he's mentioning these old gravels for the first time in 1911. And he says, I keep looking. There's a constant, careful search for this older till that Willis and Russell keep talking about. I can't find much of it, says Bretz. Okay, Bretz is still in his late 20s at this stage, and he's about to go back to the University of Chicago. The main document that I didn't think we were going to go back and do more with, but we are. So it's listed again for this episode. Is this beautiful bulletin number 8, which is essentially Bretz's PhD, printed in this form, published by the Washington Geological Survey, 1913. And there's a whole chapter where we formally start realizing that the Satsop red gravels are a big deal to Bretz. Thanks again to Trevor Contreras from the Washington Geological Survey, who connected me to Kelsay and connected me to Mike Polans and Andrew Sadowski just down the hall. So there's been a bunch of email chatter in the last few days related to this topic. So now I go to the printed notes from the 1913 document, Bretz's PhD, essentially. Keep it fast. Now on page 10, he's talking about the Chehalis River Valley, the 2 ice advances, but now he's realizing that this meltwater is coming through specific gaps in the rock hills and thence down to the Pacific, down the Chehalis. And he notices that the Admiralty till is not deeply weathered. That's not red and whatever. But he's noticing that there are some of these Satsop red gravels, the topic of today's episode, that are deeply weathered drift. He assumes it's from the ice somehow. And everything but the highly siliceous material, I'll be coy about that for now, far surpasses the alteration of the Admiralty ice. Bretz is also noticing in this 1913 dissertation that there's scattered erratics here and there, big boulders, that for the first time he's writing about being transported possibly by floating ice in marginal lakes. Again, red, Vashon. Still in the 1913 document, now on page 39, water discharging from Puget Sound forced into stream valleys to the south. That's our breadbasket today. And now he's getting into these old gravel deposits. And I want to read a couple passages from page 39 through 42 as fast as possible. The pre-Vashon red gravels of the Chehalis Valley. The maximum extent of the Puget Sound Admiralty Glacier is not known. Old drift, presumably Admiralty age, underlies the Vashon terminal moraine in the vicinity of Little Rock, but it's not known beyond that location. There is, however, an old gravel deposit in the Chehalis Valley, found at intervals from Gate, that's a town, to the ocean, and thence along the coast, which very probably Pleistocene in age, a portion of which may be outwash of the Admiralty glaciation. So he's like, okay, I got a bunch of outwash gravels. They're red, they're heavily stained, they're not fresh like the Vashon. Are they tied to the Admiralty, or are they from an even older ice advance? I mainly have Kelsay on to see if she can help us with modern techniques, figuring out the age of these red gravels. And are all the red gravels in one deposit? Is it as simple as Bretz is pointing out? But Bretz is contradicting himself on the age of the Satsop red gravels as we go from year to year. That's why I'm spending so much time on this. Yeah. The gravel is deeply stained by iron oxide, possessing a true ferretto color almost throughout. Its pebbles are so softened by decay that a blow of the hammer will break them easily. Most of them can be carved with a knife, like hardened clay. No granite and no metamorphic or sedimentary rocks were found among the pebbles, the deposit being composed almost entirely of fragments of andesitic lava. Now that's confusing to me. I didn't think it was entirely andesite, but maybe he's talking about one particular drainage that I'm not aware of. I want to keep going though. He's got some photos near the village of Satsop and Elma. He not only has the Satsop River gravels, but he can get up on top and say that these red gravels have a flat top. They're actually a terrace within the Chehalis River Valley. So he does this, and I'm starting to get a headache because I can't picture it. And so I flash forward. Kelsay, 5 minutes and I'm coming to you, I promise. I flash forward to the notes that were discovered 4 blocks away from Jim O'Connor's office. That's another part of the story. But in those notes is a draft of a paper that I don't think Brett's actually published, but I've given it to you anyway. It's on the website. So it looks like this. This is from Brett's notebooks from 1916 when he was actually working for the Oregon State Survey or whatever they call themselves at the time. And this is the one that really helped me. Yeah, again, thanks to Margaret in Spokane and Jeff in Portland for helping us find this. So I'll let you read the details here, but this is the chronology. It's an outline of the Pleistocene history of Western Washington. This is what I needed. So I want to show you my Sharpie cartoon, and we're coming to Kelsay. There's also an abstract from the year earlier on the Satsop and other things that I had to get through interlibrary loan. That's the whole extent of the abstract, but it's fun to see his evolution of thought. Cut to the chase. In the abstract, here's something familiar, and I'm adding our marine isotope stages that we know. But Brett's is also now in this abstract from 1915. He's starting to wonder is this totally an ice story? And he's also introducing the concept that when you have the Admiralty ice sheet, you apparently load the crust, and so you subside the crust, you depress the crust, and you fill the valleys with gravel. And then when the ice goes away, you uplift the crust, and you start incising. Uplift intensifies the erosion, so you start scooping out a bunch of the spuds. And then you bring an ice sheet in nearby again, you depress the crust again, and you fill it. Now he's reasoning this out with cross-cutting relations and elevations. He's got his aneroid with him, the whole thing. He doesn't know about earthquakes. He doesn't know, I don't think, he doesn't know about Cascadia subduction zone. He doesn't know about tectonic drivers for uplift events, but he's just from this glacial frame of mind, he's finding evidence that we're depressing the crust and then lifting it, depressing the crust and then lifting it. It's an interesting theme. He expands on it in that drafted outline that I don't think he ever published. So, okay, more than 5 minutes. Sorry, Kelsay. So he's got the pre-Ice Age mature valleys. That's his first chapter that he's worked out in the Chehalis, in the Cowlitz, and by now he's down into the lower Columbia. But that's ahead of our story for today. These are like, quote unquote, the John Day beds of Russell, even though he didn't say it that. Now he's saying, well, I don't know, man. These Satsop things, the red gravels are so stained, I wonder if I can tie them to the Dewado. Again, nobody uses that term. And remember my color scheme. If I'm using purple, I'm just trying to keep track of what his thoughts are. Maybe he's like, well, maybe the Satsop is way down here at Pleistocene, but maybe it's way like stage 12. Just from the appearance of the deposits, the fact that he's got lots of this Satsop up on the divide between Chehalis and the Cowlitz. I'm about to head for the money shot here in just a second. Don't give up on me. Then he's got an uplift event interglacial. Then he's got another till. He's got some Admiralty tills that Admiralty gravels that he's tying with Admiralty till, and then the Vashon. Get to it. We've seen this. Let me look at it again while I find yeah, good. So it's these divides that are being crossed on occasion, but we are now in the Chehalis River Valley, and here's what I think might be most helpful to us today. Now, if you were with me this summer with the field videos I was doing in this fall, I had sketches like this with the Yakima Valley Glacier and with the Icicle Creek Glacier. And I had these nested terraces of different ages. The work of Stephen Porter, University of Washington. Well, as far as I can tell, this is what Bretz is working out a century earlier with a bunch of what he assumes are outwash gravels. And if you can see, I've colored each of these red. So these are the Satsop gravels that Bretz in writing is assuming is the deepest fill, hundreds of feet of these red gravels. But then you scour out most of them. Then you bring in a younger batch. You scour out many of those. Then you bring in the youngest. And the last thing I'm doing is please remember that the color scheme is real. And I'm wondering if our Satsop gravels really need to go back to this vintage, or does Kelsay have some modern techniques to put us here, or even are there Satsop gravels up here, although I doubt it. They're red, but they're not red like the marker is red. Okay, Kelsay, you ready? I'm going to bring you in, and we'll just see where you want to go. Kelsay Stanton, how are you this morning?
Wonderful. How about yourself?
I'm doing great. You're sounding terrific, and
Good.
the video quality is pretty good as well. So thank you so much. I appreciate your time today.
Yeah.
Let's get a feeling for who you are, first of all, if you don't mind. So I knew you a few years ago when you were teaching geology at Wenatchee Valley College. How many years did you teach there?
Geez. Let's see, 2012 to 2018. So about 6 years.
Okay. And what schooling did you do before you started teaching at a 2-year school?
Yeah. Well, I went to Oregon State University for my bachelor's, and then up to Western Washington University for my master's.
Nice.
And then was teaching and doing some consulting work. And then I got this crazy idea to go back for more school. So I'm on the degree a decade program is what I do.
I mean, that is inspiring for so many of our viewers. It's inspiring for me too. I mean, Bretz was teaching and then went back to school. Almost all these folks did that whole trajectory. So I'm just curious what you got your master's, what was your thesis topic at Western?
Yeah, so I worked with Juliet Kreider there back when she was there. And I am a structural geologist, and I was interested in how scarps are left over from a fault at the surface, how they erode in basalt. And so I spent time puttering around away from all the floods, right? Because you don't want the floods screwing up your interpretation of how things erode.
Right.
And so I was down in Oregon and Northern California and looking at these scarps and trying to think about how they might erode through time. And if we can use that to say, here's how old we think they are, just based on their shape.
Thank you for playing along. So now our viewers are like, wait a minute. So we have a structural geology?
Right.
I don't understand. So you stopped teaching. Well, by the way, when you were in Wenatchee Valley, you collaborated with Richard Waite on some project. What was that?
I had actually from you got some notes from a gentleman who had spent a lot of time. He was a geologist looking at erratics around the Wenatchee Valley, and I had an eager student in my 200 level classes who ended up going to Central actually.
Yeah.
And he really wanted to do some research, and so I said, all right, let's try to hunt up these erratics and get them with the GPS. And along that way, figured out that some of the erratics that had originally been mapped as floated in probably were brought in by the Icicle Glacier, and that alerted Richard Waite's attention to what we were doing, because he was the one who'd mapped them. And
yeah,
so we went out and talked about it and wrote a couple papers about these erratics, and he's the one who actually said, just get off your butt, go get that degree.
Oh, Richard Waite lit a fire. Okay, yeah. Nice. Well, I think those erratics, I wanted to include that because I think those erratics might be important to us later in the alphabet between Wenatchee and Leavenworth.
Yeah.
Okay, so you decide to go back to school. Viewers, I promise we're getting to the Satsop Gravels, but so are you currently working on that PhD at the University of Washington? And if so, why are you in Spokane?
Yeah, so I will be done soon.
Okay.
I need to be done soon.
Right.
I am in Spokane because I work for Washington Geological Survey. I guess we moved over here not because I was working there yet, but I do work for the survey, and I'm over here in Spokane. Good. So quite a ways away from Western Washington, we'll be talking about today.
Yeah.
But yeah, along the way, I've been working on this degree at the University of Washington, and Juliet Kreider is my advisor again. So she had been at Western through all these years. She eventually went down to University of Washington. And I was fortunate enough that she took me back. So
I'm sure you're a good student, and she was thrilled to be able to work with you again.
Yeah.
Okay, I think that background's necessary to get a sense of this, because I have a couple of your publications for the viewers, and at first glance you're like, well, this is just a geologic map, I guess, and a pamphlet associated with it in the areas we're talking about in Western Washington. And then the brand new paper doesn't appear to be Ice Age flood related at all. So I'll ask you, why do I have you on today, Kelsay? What is the intersection between what we're talking about and what you've done out in the field?
Yeah. Well, so I guess a good way to start is just, why was I even out in Western Washington anyway?
Yeah.
And around Willapa Bay and Grays Harbor are these terraces. They're marine terraces is what they've been mapped as, and they're uplifted above sea level. And there have been some speculation about their age, that they were late Pleistocene. And so, you've already got this stages, which is so great, because then I could talk about them in stages. They were thought to be, marine isotope stage 5 to 2, that no one really knew, right? And so that could be important, because if they're uplifted, it means that something has happened tectonically to uplift them. And being a structural geologist, this is what drives me, what's driving this uplift. And so I headed out there, but these terraces were mapped at a pretty poor scale. And so originally, when they'd been mapped, the USGS geologists and the Washington Geological Survey had been looking for coal and oil bearing sandstones, right? And they didn't care about the overburden, the quaternary. And so they just mapped it, grouped it all together. And so before I could even think about how much these have been uplifted and how old they are, I actually needed to map them in better detail.
Okay.
And so that's what the map is that you have there. That's mapping at about a 1 to 24,000 scale, so better detail. And then along the way, I need to know their ages. And so I did some luminescence dating from some of those deposits out there. And luminescence dating is a way to think about how long a sediment has been buried. So how long has it been away from the sun? And so it's really good for fluvial and stream-related sediments related to beaches, and so it's a relatively new technology. Archaeologists have actually been using it for a while. Geologists were kind of getting on board with it in the past decade or so. And I know you've talked about Larry Smith before. He does a lot of this over in Montana, the luminescence dating. So that's why I'm on here, because some of these gravels are what Brett was talking about. Apparently, I mean, he calls them out in that paper, and wondered about their age. And so there's a whole bunch he talks about in that paper. A bunch of it over here on this side of the mountains I haven't thought about yet, but right around Willapa Bay and the Chehalis River there, I've spent some time thinking about it, and also worked with some of the survey folks who've mapped in there and done some additional mapping and dating.
Perfect. Thank you. So let's do two things. Let's verbally have you cut to the chase with what age you think those red gravels are. And secondly, as soon as we do that, let's share your screen and have you zoom us around a little bit and just get our feet wet. And then we can the third thing might be then just kind of talking about this dating technique that Brett's would have killed to have, but didn't have, of course. So how about the first one? What age do you think we're talking about?
He actually is referring, as far as I could tell, he's talking about two different sets of gravels.
Okay.
And the youngest is probably marine isotope stage 7, maybe 6, maybe 8, probably 7. So it's at interglacial.
Let me try this. So are you, so if this is the Chehalis.
Yep. They'd be the blue.
The blue.
Yeah. Like you, I'm not that interested in the red here.
Okay.
Last glacial maximum, there's a lot of work on that. I like the older stuff.
Sure. So you're thinking, are these to me, these are the red gravels, and these are kind of
remember I said that he's talking about two different things out there when you read his descriptions. And he also is noting that there's these gravels that are making up these cliffs in Willapa Bay. And those are pretty key to my story, because they're actually where there's some wave cut terraces that then since have been uplifted. And those are much older. Those are actually beyond the dating capabilities of luminescence dating. And, if someone wants to go dig through my paper, they can figure out my logic on how I get to their age. But they are probably older. They are mid to early Pleistocene. So, getting much further back, maybe even further back than marine isotope stage 12.
Okay.
And maybe even early Pliocene. And that's based on some fossil evidence and some other methods. So
are those these old red gravels too?
He calls them, he has two different in that paper. He's talking about, he doesn't think, as far as I could tell in the paper, that they're two different kinds of gravels.
I see.
But what I read through is that the locations, there's these two different gravels, and then when I go out there, they're actually two different gravels that are different ages. So
you've split his Satsop gravel formation.
Yeah.
You split it up into 2 or even more units.
Well, possibly even more.
Yeah.
He doesn't talk much about the fine grained stuff out there, and I did a lot of work on the fine grained stuff.
Sure.
And those are even younger. Those are 5. Those are really stage 5.
So thanks for playing along. So one more time, if we're just taking my cartoon, you like this as stage 6 or 7, something like that.
Yeah.
And that works with my color scheme. Okay, great. And then Is this the one you think goes back way before even maybe stage 12? There's just no way to keep track of time with these higher and oldest gravel fill?
Yeah, and those ones I haven't mapped a ton in the Chehalis Valley all the way down. So I haven't seen in the Chehalis Valley those old ones, but right along the coast, what he's calling, what he's describing as these coastal cliffs, they are old.
Okay.
And they are, maybe even Pliocene.
Yeah. Well, I mean, I don't know how much it matters for what I'm doing, to be honest, because
Right.
we're just finding these breadcrumbs that don't. Let's not tease it anymore. You saw some of these red gravels that have these beautiful white stones in them.
Yeah.
And those quartzites are the exotic breadcrumbs that Brett says this has to be stuff coming from Eastern Washington. So is it fair to say that as you hop from Chehalis Valley to then Cowlitz and Willapa and then finally down to the Columbia, you're just picking up more and more of these blonde quartzites?
Yeah, and I actually think that there's even maybe a little bit of lumping. You and I have talked before about lumping and splitting, right?
Yeah.
And all scientists do it. We either lump stuff together or split it, and it depends on the questions that we have and the stories that we're trying to tease out. And I think that there are the ones that are maybe important to Brett's story, and I'm not sure he totally realized it at the time, but they are the quartzites that are really along the Columbia and head over. And there are some quartzites in the Chehalis and around Willapa, but they are not as abundant as in the Columbia. And I think, they certainly are not coming from southwestern Washington. There's no quartzite out there.
Right.
And so they could be coming from the Puget Lobe, from somewhere to the north. They're definitely not coming regionally. But I think those breadcrumbs that are important to his story are kind of along the Columbia River.
Yeah.
And I mapped some of those.
You did?
Too. Yeah.
Well,
but
this is perfect. So you're so good. Thank you. Yeah. Let's share your screen and let's just learn some geography. And viewers, we're going to kind of come to you in about 10 minutes. I'm thinking we have about 1,000 watching, and we can go wherever we want. We can get into the purpose of your project, which of course is not. You're not doing a Brett study. You're not doing an Ice Age flood study, and we can certainly go there. You maybe are like itching, like, come on, let's talk about my work, man. Okay, Kelsay, let's try this. And yeah, especially if you can zoom us in at some point.
I will here in a second. I wanted to just get everyone oriented. I'm over here in Spokane.
Excellent.
And you're right there in Ellensburg.
Thank you.
And the Columbia River does this weird, it comes all the way around, does all of its weird thing.
Yeah.
Okay, and then here's where the Puget ice lobe would have been. And way over here.
Oh, love it.
In southwestern Washington. So here's Olympia.
Thank you.
And the Chehalis River does this weird turn also. And the Cowlitz does its weird turn. And right in here is that divide that you were noting in your map.
Mm-hmm.
And so out here, we have Grays Harbor and Willapa Bay. And all along the edge of Willapa Bay and south of Grays Harbor here were what were mapped just as quaternary terraces, a single unit, just one unit. Basically, everybody mapping out here with all this rock over to the east, they just thought, well, this is not worth looking at. It doesn't have coal, it doesn't have petroleum. This was in the 1960s.
Okay.
So we don't actually care about it that much. But I'm a geologist that thinks about faults and folds, but I like to think about it in the quaternary. Like, what's the stuff that's affecting us?
Yeah.
And so a lot of the mapping that I did was in these highlands and then along Willapa Bay, all the way to southern Willapa Bay, kind of right around here.
Huh.
And that's what that map and that paper are talking about. And you'll get into parts of that paper I'm the first to admit I went into the methodology, and you might look at it and be like, screw it, I don't want to look through all this methodology.
Right.
So you could really jump to some of the conclusions if you want, but if you just want to look at the maps, those are there too. And it splits 9 units. So 1 unit is what I had, and I went down. I split into 9, and up here, the highest portion. They weren't even marine terraces. So the idea had been that these were marine terraces, all of these out here. And these marine terraces, sea level is a great datum level. Like, here's where we start, and now we're above it. And I found out there that these are not all marine sediments. Like, there's a lot of fluvial stuff. And that photo that you showed of my scraper tool,
Yeah.
That's in some of these gravels that are like 130 meters above sea level. Yep, right there. So, so we're getting pretty high elevation, 300-400 feet. And that one right there, that's a different one. And that's the older story. I'll get to that one in just a second. But these higher ones up there, I did point counts on them. And basically what that means is I took a bunch of sections and then determined what the rocks were in there. And there were a lot of granitics and a lot of metamorphics, non-quartzite metamorphics. There actually weren't a ton of quartzites. There were a lot of andesites, which I heard you say earlier. What are these andesites?
Right.
Well, none of those rocks I just talked about are from right around that area. Like, that area is crescent basalt and sandstones, and all this other stuff is coming. It must come from the Puget region, right? It has to be being brought down from the North Cascades in Canada, and so it darn sure looked like outwash to me. And I got a date on some sands there that came back at 195-ish. So 195 is sort of right on the cusp of marine isotope stage 6 and 5.
Okay.
Right? So your stage 6 is your double bluff. That's what we call it now. So that would have been a glaciation, and 7 is a interglacial. So 195 is right on.
Yeah.
Between 6 and 7 there.
Sure.
And so then I went back up the Chehalis to these Satsop terraces that Brett's had been talking about, and took some samples there, and they came back like 200-ish plus or minus. They actually overlapped with my other age. And those have some more quartzites, but they're also just chock full of granitics and andesites. Like, they're coming from the Puget lobe.
Well, hang on there. That's interesting to me. So that you're up on top of the Satsum terraces, like there's only a couple of the terraces that remain. Most of it's been destroyed.
Yep.
Are you saying your date is almost 200,000 years old for the purple, at least near Satsop itself?
Yeah, well, I think that probably the Satsop terraces, so you don't clearly see these multiple sets. That purple is you don't see those very frequently.
Okay.
And the big things that he's calling the Satsop terraces that are really, really present, you can go and look at them in LiDAR, like they just stand out. Those are coming at your blue there. Your
okay.
Either from the double bluff glaciation, so outwash, or maybe from the interglacial. And this is where I'm less clear about, because some of the other survey geologists who've mapped out there, they have looked at these deposits of fluvial gravels all over around Olympia and south of Olympia and down into the Cowlitz. And when they take a bunch of dates, their dates sort of overlap with mine, but on theirs are higher. And so they're thinking that these are interglacial, probably from marine isotope stage 7. And I don't know. I go back and forth. My first thought is this is outwash from Double Bluff, but then I see some of their dates, and I've been out to their sites with them, and they look really similar. So I don't know. That's splitting a lot.
Yeah. Well,
But that's still right. We've now gone from, and this is something I like about geology. It's like a Sherlock Holmes mystery. You have this question, and as time goes by and more people look at things, maybe we get better technology, but
yeah.
not always. I mean, a lot of these early geologists, they had it spot on. You start to narrow the timeline, and so you go from like all of the Quaternary, all of the Pleistocene, down to a couple marine isotope stages, and that's getting pretty darn good.
Yeah.
For geologists, that's pretty good.
Well, I'm loving this. To me, there's like two narratives at once with these deposits. You got these valleys full of gravels. You got the same looking gravels along the shoreline. The two things you're trying to figure out is, one, where are we age-wise? And the second thing is the lithologies. How much of this is related to the ice sheets over Seattle versus how much is related to stuff coming down the Columbia that's got nothing to do with ice?
Yeah.
So it's like there's competing narratives going on with the same deposits, and that probably informs how much you want to split things out versus lump things together.
Yeah, well, and I think this philosophy of science, I guess in general, of lumping and splitting.
Yeah.
It's sort of, sometimes it's really beneficial to think of everything. Like, let's think of everything in the Quaternary. Let's just think of all the gravels that we find all over the place that are past 2 million years. And are they telling us something? Like, we have a bunch of erosion. Is it because there's regional uplift? Is it because there's a bunch of glaciers? That's kind of an important big picture story.
Yeah.
But then zooming in on an area and splitting stuff apart and saying, okay, what else do we have going on here? What is this telling us about this local region? Which, the splitting that I did, I think tells us, this is this is jumping out of the flood story, but I think it tells us that we have some active faults out in the Willapa Bay area, which is exciting for me.
I'll bet you the viewers are going to want to go in that direction. So I think I have one more ask for you with Google Maps, and then viewers, we're going to come to you. So my last ask is, if we go back to Google Maps, can you just zoom us in quite a ways and give us a little travelogue for the Satsop red gravels that Brett's was describing? Yeah. And when do we start picking up those quartzites?
All right.
And as we go, just specific valleys or places that you remember, just generally the red gravels, but then more specifically where we pick up a lot more of those blonde quartzites, because that's going to be our next episode for sure.
Yeah. So first of all, what he calls, and he says right away in that paper, what he coins Satsop Gravels. This is the Chehalis River. There's Elma. You could see these terraces.
Look at that. Yes.
They just stand out really beautifully. And you see them on this side too. And this is where, this is where I'm getting ages of right on the cusp of marine isotope stage 6 and 7. And the same for some other mappers at Washington Geological Survey.
Yeah.
And they have some quartzites, but not many.
Okay.
And then you come down, here's Aberdeen, Cosmopolis, and you get up into these highlands around south of Grays Harbor. And this is where I found, that's where those photos came from.
Okay.
And some sands and gravels, and this is coming, with a 195,000. So marine isotope stage 6, 7. And then he also is talking about the cliffs along Willapa Bay. Yeah. And if folks go out there, right now it's kind of gloomy, but in the summertime it's nice.
Yeah.
And you'll drive along the northern part in particular, and you'll see these big cliffs. And also over here at Bruceport, you can get out and walk along here when it's low tide. And in those cliffs are what he also describes as Satsop gravels. They're much redder. They do have some quartzites. And that's that other picture that you had that I said, I don't want, that's later. And these are old. These are quite old. So not that one.
Hang on.
Yeah, those ones. See, and look at those. These are old. It's almost like a conglomerate. Like it falls off the cliffside as a giant boulder.
Huh.
And these are much older. These are probably mid to early Pleistocene. So again, at the start of the Quaternary. So here I think what he had done is sort of grouped all those together. Like we've got these reddish gravels.
Right.
But then, and can you go back to my map for a second? Otherwise I'll start rolling my arms around. You come way down here into southern Willapa Bay and out here along Sunshine Point. And I'm not the only person to map these. Down here, Ray Wells, who's a USGS geologist, all around the southern side of Willapa and on Long Island. These are gravels with lots of quartzites. And these are big quartzite cobbles.
Wow.
And they are reddish, but they are not nearly as weathered as the stuff further to the north that I was looking at. And I think that this is the Columbia story down here. These are telling us a story about what I think about the Columbia. And I think that I think these things to the north were sort of red herrings. We'll call them red herrings because they're red. Well, they were red herrings for Bretts. I think these quartzites to the south are coming from Eastern Washington. And I think that those are part of the story that is really pulling him, or ended up pulling him that direction. And they need more work. There's no doubt about it. There's some interesting stuff there, telling us something about the Columbia. I just didn't. You can only do so much before you got to get the degree done, right?
Well, no. That's not super controversial, is it, to say the Columbia River dumped into the Pacific there because of those?
I don't think so.
I think there's some CRBs there too, right?
Well, yeah, weirdly, isn't that cool? When we've got these Columbia River basalts out there. But yeah, and there is actual deposits, not as cobbles. There are actual flows, But no, I don't think it is controversial. I don't know. Some of your future guests, you should bring it up and see what they say. I sometimes have talked with them, but I think this story changes now and then, and I don't think that would be controversial at all. And this is getting really arm wavy, but I know offshore. You were talking with Joel about the Astoria Canyon offshore, and when you look at the bathymetry, the Willapa Canyon offshore it's really pronounced too, almost as much as the Astoria. So I'd be okay with it. I'd be okay with maybe the Columbia sometimes going out through the Willapa instead of where it is now.
Well, regardless, and viewers, go ahead, put your uppercase in. We're going to come to you. Regardless, Brett's is stumbling into those quartzites, and in some cases, he's like, 50% of these cobbles are quartzite. What the hell is going on? And
definitely.
Where is the stuff coming from? And that he just starts working his way inland from there. So let's let the viewers guide us. And Kelsay, if you want to toss in a couple things about the scope of your project as we go, that'd be great. But you've done a beautiful job here today. Sky Cooley asks, are the oldest red gravels that you studied Pleistocene but pre-glacial? Yeah.
So those ones that are making up the cliff lines along Willapa. I would guess that they are. They're pretty darn old. There's a multitude of testing dates. Yeah, those ones. But basically what it comes down to is nearby there are fine grains. You can actually see them below that. There's fine grain sediments there that have some fossils that put them somewhere between late Pliocene and at the most mid Pleistocene. So this is definitely before the glacial periods that we're actually talking about, before marine isotope 12 and younger. So
thank you. Yep. Rock Lover asks, I think I observed some of the Satsop Gravels in the Mima Mounds. Yes or no?
Oh, the Mima Mounds. We love those, don't we? I don't know.
Yeah.
I haven't looked at the Mima Mounds very much, except for the same as all of us go out and go,
Right.
look at those things.
Exactly.
How'd they get there?
Fair enough. Keep moving. Square Peg asks, tectonically, was there a time when the Willapa Bay area was lower than the Astoria area?
Probably not lower than the Astoria area. But when we're talking about, there's a couple different things to think about there. First of all, everything out there is uplifting tectonically, right? And if you manage to get through that paper, you'll see that's what I figured out. And I'm in the process of trying to figure out where those faults are at right now, but that's a different story. Okay. But so yes, things have uplifted, and they have along the coast too. Like we see uplift all along Cascadia, all the way down through Oregon and Northern California. But I think what is more important from that question is that when we have these interglacials, so during those odd marine isotope stages, sea level is higher, and when we have the glacials, sea level is much lower. And so all of these rivers have a new base level. So their base level is where they're emptying into sea level. Yeah. And if all of a sudden that base level drops, they have to readjust. And then the base level rises again, and now they have to fill everything in. And so sometimes when you're looking at, it seems like uplift and down dropping, but it's actually the sea level going back and forth. And then we also have uplift to complicate it, and depression from the ice sheet. So that's a really interesting question. And yeah, Willapa, during marine isotope stage 6, the water was like 200 meters lower than now, or something like that. It was out there.
That was really helpful right there for me. I've always been confused by marine terraces and base level, and I don't quite have. I still don't think I totally have it, but that was a step in the right direction for me. Thank you. Good. Elaine wonders, would you mind just telling us the basics of luminescence dating?
Yeah. So certain minerals, quartz and feldspar, are like little rechargeable batteries. And when they are covered up from sunshine or any light, they start to trap natural radiation. And they have these little traps that are basically within their crystalline structure. I won't get into it much more than that. And if you expose them to light or to heat, then they empty out all of that energy. And then when you cover them back up, then they start recharging again. And so luminescence dating, you go out to these sands, and you have to get the sample without it being exposed to light. And so you use a pipe that is a metal pipe, and you pound it in there. It's way harder than it sounds. Or you could go out at dark. You could go out at night with a red lens on your flashlight and try to get them that way. But it's, people get suspicious when you do that. And so you get these samples, and then you take them back to a dark room, and basically you zap them with a laser, and it releases energy. And that energy release is correlated to the amount of time since they've been covered up. And so that's luminescence dating. And you could do it on quartz or feldspars. I did feldspars out there. And it's it's really useful, but there is a point where you can't use it anymore, because basically you have a battery, you could keep putting in energy, but it can't fill in anymore, right? It's as full as it can be. And so if it's been buried long enough, like, you can only get so much in there. So it's not very useful to old, this period of the Quaternary that is about 300,000 or 400,000 and older. You can't really use it that much, but it's really good for 200, 300, and all the way to present.
Very good. How about 3 more? You're just a natural. You really are. Lots of nice comments about you.
Oh, well,
that'll be fun to read after the fact. Bob is wondering, did the Columbia River used to flow into the Willapa Bay?
I guess I can throw my hat into a side and say, yeah, I think it probably did. Yeah. And I don't think that's that weird.
Yeah. Mike, during glacials and interglacials, sea levels would have been at different levels from 400 feet lower to 150 feet higher?
No, not quite that high.
Okay.
Yeah, there's a lot that goes into figuring that out. Especially with the depression related to the ice sheets, and it can make it seem like it was that much lower. But the highest during marine isotope stage 5 was maybe 20 meters higher. Maybe.
I think Mike is leading to the question: have these studies extended to offshore deposits, and how far would they go, or something like that? So you're on land.
Yeah.
It's a totally different world, like we talked about with Joel. Like it's a totally different community trying to.
Oh, definitely. And I think I can't really answer that in a whole lot because I'm not part of that community. But I do know that there's been some really fascinating studies with offshore sediments and also with the turbidite record offshore, which are underwater debris flows in these canyons.
Mm-hmm.
But I don't know much beyond that. That's something that we need to work on, crossing from offshore to onshore.
Yeah. Okay, Dennis is going to ask the last question, and it's an easy one, I think. Maybe it's a hard one. Kelsay, do you have advice to new students coming into these fields?
Advice to new students. Geez.
You can take that anyway. Maybe it's a hard one. Like you had success getting people when you were teaching at Wenatchee Valley to go on in geology and continue. How did you sell them on geology?
Well, I think geology, okay, that makes it much easier for me to answer. I think one of the things we don't really think about in geology, we think about, people always just say, oh, geologists, you think about rocks and earthquakes, right? Where's the gold? But really, it is such a broad science, and there are so many ways that you can apply your interest to it. So if you're into computers, like right now, big data and computer learning, all that is huge in geoscience. And then you can do chemistry, you could do physics, you could get out in the field. I think that if you're interested in thinking about how the world works from a physical manner, you can really find a niche in geology. You don't have to just think about it. If you don't like to be outside, there's a lot of stuff in geology that you could be inside. And so that's what I always try to instill in my students. Like, we're not all these grubby folks out pounding on rocks in the mud. Some of us are, but not all of us. And so there's a lot of ways that you can find where your interests meet in geology. And I think that's, you just need to be persistent and ask questions and reach out to people. That's the other thing. The geologists, reach out to them, ask them what they're doing, ask them how you can get involved. That's how that student got me finding a project for him in the Wenatchee Valley. So
yes. Hey, great job this morning. I really appreciate it. And, you're over there in Spokane. So I don't know, we might be bugging you again once we get over there to try to figure things out. Like, what are you doing over in Spokane? I know you're working for Washington Geological Survey, but is it related to what we're talking about today?
No, it's, I'm in mine reclamation. So I do surface mine reclamation, help with that. But I can't help but look at the stuff out here. So I do.
Okay. Well, thank you so much for your time. Really appreciate it. Great job, Kelsay. Thank you so much.
Yep. Talk to you later, Nick.
Okay. Bye-bye. Kelsay Stanton, Washington Geological Survey, today based out of Spokane, Washington. But Kelsay is continuing her work as a doctoral student at the University of Washington, about to finish up. That's the hope. So really enjoyed that. Hope that you did too. We've got a couple final thoughts that I'd like to share with you, just odds and ends basically, and then we'll sign off for today. We still have almost 1,000. Terrific. Well, what else do I have here? Just a reminder that we are about done with, I keep saying it, but I think I mean it this time. We're done. Come on, man. We're done. We're done with the Puget Sound, or Puget Sound, not the Puget Sound. Got it. So today we were here, and this area of Southwest Washington that's quite foreign to me, I must say. I really enjoyed Kelsay's help today and very much appreciate it. Please remember from the last episode that Chamberlain and Salisbury are part of the scene. And now that I can get my head out of the way, we've got Joel's 4 mega glaciations, as he calls them, kind of like that. And we're taking Joel's plots and trying to assign the 4 most likely dates for major glaciations. And I need to remind you, I'm kind of forcing people to do certain things. Like I even kind of did it with Kelsay a little bit today, and like pushing certain things. And it's a stakes-free thing. Like there's no peer review here. There's no gotcha moments. We're just sharing our thoughts, and some of them are well documented and published, and others are just kind of thinking out loud. So something like this from Joel, again, I haven't heard from him yet, going, "What are you doing? Please stop saying these." He didn't publish these dates. He's just like the rest of us. Even though Joel Gombanner's a really bright guy, he's taking data and he's basically trying to give us some working numbers. So if you have at some point problems with some of these plots and like show me the data for that, like I can show you the data, but it's really just Joel and others just gifting us and Kelsay today giving us a gift of thinking about the quartzites being dumped into the Pacific Ocean where the Columbia River used to go. That's not her published expertise, but she's got the spirit of what we're trying to do here. Speaking of which, nickzentner.com, click on the word floods. I mean, I continue to be completely out of control. Well, I can't stop. I cannot stop. So this is session L. And look what we have here. Dean in Spokane and quite a few others got me to this 7th annual USGS publication from 1886. And like, who cares? It was like a 700-page document. Well, I just grabbed the T.C. Chamberlain report written in Beloit, Wisconsin, July 1st, 1886. And that's the first documented place where we have Glacial Lake Missoula. So it's fun to just kind of grab things here and there. And in some cases, I'm asking for help like after the show's done. Have you noticed that? You're like, you just finished the episode and now you're asking for help? I don't get it. Can I remind you that I'm having a blast doing this with you, but also I'm doing 3 boiled down, dense lectures on Brett's based on all the stuff that we're doing together. So in April, these 3 filmed downtown lectures, which I assume will be watched like from a lot of people, I want it to have the best possible stuff in it. And it will include photos from room 180 of Science Hall, University of Wisconsin, that sort of thing. Even though we're done with that episode, I'm getting some of these things to put into those polished episodes. So I'm basically workshopping certain things with you. You haven't figured that part out yet. All right, so here's the 1910, the 1911, the 1913 Brett's. Yes, you've got the abstract in digital form that I was putting under Docky. Here's that draft. And some of this was published in 1917, but some of it wasn't. So even Brett's is just kind of sharing ideas with us. Kind of, He didn't have a say in it, but his family did. This, I think Sky Cooley and maybe 3 others sent me this really nice little essay written by Alan Schneider. I don't know who that is, but back 20 years ago, he wrote a nice little piece showing the connections between Chamberlain and Salisbury and this guy, Colley. All sorts of cool stuff. Chamberlain's son is going to be a character. T.C. Chamberlain named his son Rollin after Rollin Salisbury. And I think I just read it quickly last night. I think Salisbury was like living at the Chamberlain's house or something. So there's like an older Rollin and a baby Rollin. It's fascinating. I think it's fascinating. Here's Kelsay's published mapping from Grays Harbor, and I took some of her quads and just combined them with her pamphlet. Hope she doesn't mind that. I'm not sure I have the entire published whatever, but there's plenty of detail here where she has split out some of these units. And, oh yeah, here's, finish the thought. And here's Kelsay's brand new paper, which is more along in keeping with her PhD that she's working on. We didn't even really get to this, but she's doing the work out there to tie some of those red gravels and some of those units and getting some dates from those gravels and therefore tying it to Cascadia subduction zone earthquake history. So there's much of this is beyond me. She's a bright gal, but there's some familiar looks to some of the deposits we were talking about and her OSL dates, her luminescence dating. Boy wonder, Joel Gombiner. Again, the emails continued to pour in. I'm so grateful for all the energy from all of you, from so many of you. And a number of you said, hey, could Joel take the Milankovitch cycles and some other astronomy stuff and plug it in with his other squiggle plots, charts that he's been doing? So I got enough of those emails from you guys where I finally just forwarded one to Joel, and I said, I keep getting this email, more or less. And he's like, oh yeah, I'd be happy to do that. So here's Joel taking he's comparing the orbital parameters to the global ice volume to the Antarctic temperature range. So he's got, I'll let you enjoy this, but so Joel Gombiner continues to come through for us. Thank you, Joel. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I need to calm down. That's another 11 new papers. You're like, you really expect me to read all that stuff? I don't know. You can do what you want. Yeah. Oh, sorry. Yeah. So we're heading here. I don't know if the breadcrumb thing worked for you. To start the episode, we talked about breadcrumbs and following breadcrumbs and basically going upstream. Well, what stream are we going to go up with breads? We're going to go up the Columbia River. And this Thursday and next Sunday, we will be working our way into the Columbia River Gorge, which is the state line between Oregon and Washington. We'll go back to Bretz's timeline. We will continue with those blonde quartzite discussions. I'll probably even have a couple of blonde quartzites in here with me to show you because they will be key for us. And we will see how and why this gets Bretz and his University of Chicago students not only into the Columbia River Gorge, but eventually far enough east to get to the channeled scablands of eastern Washington. A toast to you. Here's to you for joining us today. Thank you. Are we still rolling here? Here's to Kelsay Stanton, Washington Geological Survey, for her time and energy today. Thank you, Kelsay. Here's to the health of you and your relatives and your friends as we say goodbye to 2023 and look forward to 2024. Here's to a healthy year upcoming. Happy New Year to you all. Bring the confetti in, please. We made it to the end of 2023, and onward we go to 2024. I don't have to show you the calendar again. You know we're on our regular schedule. I'll see you this coming Thursday, January 4th, 2024 at high noon for a solo show on something in the Columbia River Gorge. Thank you. I love you, and goodbye from Ellensburg, Washington, USA. I'll see some of you at Dry Falls in a couple hours. Goodbye. Be careful tonight.